Good evening students. In today's class we are going to discuss about acids and bases. First and foremost thing, how to define these acids and bases. We can use Arrhenius theory. So what is Arrhenius theory here? If you take a substance A, add water to this, then that will give you H plus ions, which you call it as protons, or you can also call it as hydronium ions. Then this substance A is called as acid. Example, HCl in water gives you H plus and Cl minus. So this H plus will combine with H2O and can give hydronium ion. So definition can be either ways. The substance which gives H plus ions or hydronium ions is called an acid in presence of water. If you take H2SO4 in water gives 2H plus and SO4 2 minus. So sulfate ions are liberated. So here we can call it as an acid as it is releasing H plus ions. Now what is a base? A base is a substance. If you take B, add water to this and gives OH minus, which is known as hydroxyl ions, then you call this substance B as a base. Example, NaOH in water gives us Na plus and OH minus. Because it is releasing OH minus ions, you call NaOH as a base. Some more examples are potassium hydroxide KOH in water forms K plus ions and OH minus. You can also take calcium hydroxide in water gives Ca2 plus and 2OH minus ions. So all these substances are releasing OH minus ions, hence you call them as bases according to Arrhenius theory. Now let us see the methods of preparation of acids. So very important methods. So first we will list out. First one is direct synthesis of acids. Second method is action of water on non-metallic oxides. Action of water on non-metallic oxides. And third one is by the oxidation of non-metals we get acids. So oxidation of non-metals. And the fourth method of preparation is displacement. So this is about the names. Now if you see the first method, that is synthesis. So what is meant by direct synthesis here? Take hydrogen reacting with non-metal. Always remember we have to take general equation. So if you react a hydrogen with non-metal, you are going to get acid. So let us take example. So hydrogen reacting with non-metal. So what are the non-metals? You can take chlorine, you can take bromine, you can also take sulfur. Now you get 2HCl hydrochloric acid, here hydrobromic acid you get, and H2S hydrogen sulfide. So this is the first method of preparation. Second one is if you add water to acidic oxide, you are going to get acid. Important thing is why non-metallic oxides are called as acidic oxides. So you can take examples. If you take SO3, it is a non-metallic oxide of sulfur. On addition of water, you are going to get H2SO4, that is sulfuric acid. Because the non-metallic oxide is giving you acid, this is also called as acidic oxide. Hope you have understood this. You can also take SO2 in reaction with water, you get H2SO3. So very important thing, why do you call this as a sulfuric acid, and why this is called as sulfurous acid. So the oxidation state or valency of sulfur you can calculate. Okay, so what is oxidation state and how you can calculate that? H2SO4, you take it as X, oxidation state or valency as X. Now this is 2 plus X minus 8 is equal to 0. The total oxidation state is 0. You know very well H is equal to 1 electron. On loss of 1 electron, H will gain positive charge. So H plus 1. So that's what we have given. Plus 1 into 2 is plus 2. Then oxygen with the configuration 2, 6 gains 2 electrons, therefore it gets O2 minus. So oxidation state of oxygen is minus 2. Here 4 oxygen into minus 2 gives you minus 8. Now X will be considered as, if it sends to other side, it is plus 6. Similarly, if you calculate H2SO3, taking it as X, 2 plus X minus 6 is equal to 0 and X is equal to plus 4. Always remember, when there is a low oxidation state, you get more digits, that is us. So here it is low, hence you call it as sulfurous acid. And when there is a high oxidation state, you call this as ic acid. So therefore you will call it as sulfuric acid. So hope you have understood the difference between ic acid and us acid. Now third method is oxidation of non-metals. So what is meant by oxidation? So general equation, if you write non-metal reacting with an acid gives acid plus water plus its oxide. So this is our general equation. If you take non-metal sulfur and acid as nitric acid HNO3, then what will happen? You will get this sulfur will convert into sulfate, that is H2SO4. So addition of oxygen is known as oxidation. So hope you have understood this. So sulfur gets converted into sulfate, that is H2SO4, and you get oxidized. Then water along with oxide of nitrogen, that is NO2, is formed. You want to take another example, take phosphorus with 5 moles of HNO3 gives, now phosphorus is converted into phosphate, so H3PO4 phosphoric acid you get with water and NO2. So always we have to remember general equation, example according to that we can write. Now last method is displacement. So what is meant by displacement? So generally if you write the salt reacting with less volatile acid, that means it will not be evaporated easily. On heating gives salt plus acid which is more volatile, that means it will vaporize. Example, take salt as NaCl, sodium chloride, plus H2SO4 as less volatile acid which will not evaporate. Now what we get from here, displacement of hydrogen takes place, so hence you call the reaction as displacement reaction, and you get NaHSO4. That H will combine with the Cl minus and you get HCl, which is more volatile acid. Hope you have understood this. Sodium more reactive displaces less reactive hydrogen and you get sodium hydrogen sulfate. Second example, take sodium nitrate, NaNO3, sodium nitrate, adding H2SO4. On heating, once again the same thing, hydrogen gets displaced and you get NaHSO4 plus HNO3. How did you get HNO3? Because here NO3 minus nitrate will combine with this H plus and you get HNO3. So this is about the preparation of acids. Now let us see the preparation of bases. So how you can synthesize base here? So either you can take basic hydroxides like, if you write the methods of preparation, first one is from metals, we can prepare bases from metals. So second one is action of water on reactive metals, action of water on reactive metals. And third one is action of water on soluble metal oxides, on soluble metal oxides, so metal with oxygen. Then double decomposition reaction, which we have been coming through from lower classes, double decomposition reaction. Then fifth one is oxygen plus metallic sulfide. You know sulfide is nothing but S2 minus. Then last one is biodecomposition. Biodecomposition. These are the 6 important methods of preparation of bases. Now first one is, how do you prepare a base from metals? Important thing, write down the general equation, nothing but metal plus oxygen gives base. So we can take examples here. Let us write sodium as the metal reacting with oxygen and you get sodium oxide. So this is a base. Next, magnesium you take reacting with oxygen, you get a magnesium oxide. So this is another base. What is the second method here? The second method is action of water, so H2O on reactive metals will give the base plus hydrogen. So this is the general equation. So we can take H2O plus, writing 2Na, take 2 moles water gives us 2NaOH and hydrogen. See how we can take this, we can also write it as H plus and OH minus in this way, and Na can be written like this. So we can remove 2NaOH, so therefore hydrogen is left out. Similar to this, you can also write 2H2O plus 2K gives us 2 moles potassium hydroxide and hydrogen gas. So this is your second method. Next, third one is, we have discussed metal oxide reacting with water gives us base. So in this general equation, take any metal oxide. So we can write it as sodium oxide, potassium oxide and calcium oxide. So if you add water to this H2O, you get 2NaOH, sodium hydroxide, and for potassium oxide you get potassium hydroxide, and for calcium oxide you get CaOH twice. So hope you have understood the third method of preparation. Fourth one, double decomposition. So what is meant by double decomposition? The decomposition reaction is breaking up of the respective ions. So if you write salt solution with a base, so you get basic hydroxide, which is considered to be another base. So basic hydroxide is another base and you get a salt. So this is general equation. Take salt solution, we can write FeCl3 is a salt. Once again, how can you say that FeCl3 is a salt? Add H2O to this. If you add water, what will happen? Fe plus 3 taking water gives us FeOH. So FeOH chitra is here, and now Cl minus will give you HCl. So the base is reacting with water, hence the product FeCl3 is considered to be the salt. So salt solution we have taken FeCl3. To that add another base, let us take 3NaOH. Now what is the basic hydroxide here? The basic hydroxide is Fe and OH. Here we have to take 3 OH minus, as Fe is 3 plus. So you get hydroxide as FeOH thrice. So this is your base. Salt is Na plus and Cl minus combine and you get sodium chloride. One more example, take copper sulfate. So copper sulfate is also a salt because CuOH twice and H2SO4. So base plus acid, the product is salt here. So if you add 3N, or you can have only 2 here. Why you are adding 2 NaOH? Because Cu is 2 plus, it will take 2 OH minus and you get the hydroxide CuOH twice. And the salt here, sodium sulfate is the salt. So this is about the double decomposition. So you are breaking here once and here twice, hence it is double decomposition reaction. Fifth method, we have taken metal sulfide, any metal with S2 minus, combining with oxygen on heating gives metal oxide plus SO2. See, sulfide always gives sulfur dioxide. So we can take example of zinc sulfide plus O2. Here we can take 3O2 on heating gives 2ZNO plus 2SO2. So zinc oxide is a metal oxide here. So metal oxide with water can give you the base. Next, lead sulfide plus 3O2 gives us 2 lead oxide plus 2 moles of sulfur dioxide. So hope you have understood this. Next, sixth method is the decomposition of salt. So what is meant by decomposition? The breaking up of salts. So you can take the general equation like metal carbonate. Carbonate is nothing but CO3 2 minus. So when you take metal carbonate, decomposition in presence of heat gives us the basic oxide plus carbon dioxide, because earlier we took S2 minus sulfide gives us SO2. Similarly, CO3 2 minus carbonate gives us carbon dioxide. So that's why here product is CO2. If you are taking example calcium carbonate, you take on heating the basic oxide is CaO and the carbon dioxide is liberated. Another one is CuCO3, you take copper carbonate, on heating you get copper oxide and carbon dioxide gas is liberated. So this is about the definitions and preparation of acids and bases. Hope you have all understood this.